Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied about the methods of preparation of alkane as well as we have discussed about the physical properties of alkane, and now we are going to talk about chemical properties of alkane. So what is a chemical property? So chemical property is the formation of different substance from a particular main substance that is in this case is alkane. So now because of alkane we are going to that is prepare different kind of substance. So that kind of process will involve several steps, and those several steps are basically known as the chemical property that will be shown by alkane. So now let us discuss about that chemical properties. So now we are going to talk about the chemical properties of alkane. So the alkane is been showing this kind of four properties or this kind of four processes so as to convert alkane into different kind of substance. So in that case basically conversion reaction takes place. That is, the first process is halogenation, the second is nitration, the third is pyrolysis, and the fourth is basically combustion. So now we are going to discuss about each topic in a very detailed view. So let us talk about the first one, that is halogenation. So what is actually halogenation? As we know that an alkane group consists of carbon atoms and also consists of a hydrogen atom, and all the carbon-carbon atom that are being bonded with each other has a carbon-carbon single bond. But what is halogenation actually? Because halogenation is nothing but the replacement of the hydrogen which is in alkane by a halogen atom. So now suppose if I have replaced this alkane by a halogen atom, so in this case what will happen is this H will be removed, and in that place an halogen atom, or we could say an halide atom, can be introduced. So this kind of process where we have introduced a halide atom to a alkane, or by removing the hydrogen atom, this kind of process is basically known as halogenation process. So let us talk about that also. So mainly talking about the halogenation process, this is not the reaction that happens. So the general reaction is as follows that I am describing. So the general reaction of the halogenation process can be written as RH, that is nothing but alkane itself, plus X2. This X2 is nothing but the halogen, a halogen molecule. So therefore X2 can be either Cl2, can be Br2, can be F2, or can be Io2, or we could say as fluorine molecule, chlorine molecule, bromine molecule, and iodine molecule. So this is what we could introduce so as to convert a particular alkane into a particular alkyl halide. That is, we could see that in reaction one of the X or one of the halogen atom will take away the hydrogen, and so as to form basically a hydrogen halide, and that is what that remains with us is, that is, a alkyl group and a halide group, making to be called this group as alkyl halide, while this one was our alkane and this is a halogen molecule. So this is our basically general reaction. So this is the general reaction that we are going to talk about. But talking about the halogens are being distributed into mainly that we know when it comes to the reaction, that is fluorine, chlorine, bromine, iodine, and astatine. But astatine is a radioactive element. So therefore we are going to discuss about this four kind of halogens, that is fluorine, chlorine, bromine, and iodine. So what if fluorine has been involved in this process? So the term halogenation now will be replaced by fluorination. So now this reaction will be known as fluorination if instead of X we have taken F. So therefore RH plus F2 will give us RF plus HF. So this is the kind of fluorination process. And talking about the next one, that is what we are going to mainly talk about, that is chlorination process. So this is what we are going to talk about, chlorination process. So what is chlorination process? It will be the same, the definition of that will be the same as that of halogen. That is the process in which one hydrogen atom of an alkane is being replaced by corresponding number of chlorine atom, that so as to form an alkyl halide is known as chlorination process. So in this case also, suppose if I have given an example in terms of, that is CH4. Suppose if we have CH4 as an alkane, basically known as methane. So we have to do chlorination. So as to do chlorination, we need a halogen molecule, not a hydrogen halide. We need a halogen molecule. So therefore, we know that for chlorination, we have to take a halogen molecule, basically a chlorine molecule. So that is nothing but Cl2 gas. So now this reaction will lead us to formation of, basically, one of the chlorine atom will react with the hydrogen and in this case, basically, one of the chlorine atom that was left, that is one of the chlorine atom that was left, will now replace the hydrogen atom that is vacant now, because one of the Cl and one of the H will move out in the form of HCl or hydrogen chloride, and the rest, so as to fill the valency, one chlorine will replace that hydrogen atom's position so as to form basically CH3Cl. So this CH3Cl is nothing but methyl chloride. But the reaction doesn't take place by its own. We need particular condition for that. And what is the particular condition? Because this kind of process where a methane is been involved with the chlorine, we can't directly get methyl chloride. For that, we have to maintain certain conditions, and that condition is nothing but the ultraviolet condition in presence of heat. Or if we warm methane molecule and chlorine gas and in presence of sunlight, then we could see that the reaction will proceed so as to form methane to methyl chloride. So this is known as a chemical property, because in this case, basically, we have converted a alkane to a different kind of substance, and in this case the methyl chloride is not in that of an alkane. It is not an alkane, it is something different. So that is how we have converted a methane into methyl chloride by using chlorination process. So this was one of the few example of halogenation process. So let me consider this to be called as part A of the halogenation process, for the halogenation process. And now talking about part B, that is, suppose if we consider like bromine to be replaced, bromine atom to be replaced. So now we are going to talk about bromination. So where a bromine is the one which replaces the hydrogen atom of an alkane. So now let us talk about that. So the next part is basically bromination. Even this definition will be same, but we'll have a few kind of difference. And what is that? This is a process in which the alkane will be converted into an alkyl bromide, and in this process, basically what happens is the hydrogen of an alkane will be now replaced by the bromine atom, and this kind of process where the replacement of hydrogen is done by the bromine atom in presence of bromine, and with a few conditions that should be applied, that kind of process is basically known as bromination. So now in this case, what will happen actually? Suppose if we have a molecule, the same, suppose if we have considered for methane, suppose if in this case we have considered for ethane, that is CH3. Suppose this is ethane that we have made it a reaction with, that is bromine gas. So in this case, what happens is one of the bromine atom will take away one of the hydrogen atoms so as to form basically HBr, and the rest that will be remain with us is basically an ethyl molecule or an ethyl group, because one hydrogen has been moved away with the bromine atom. So now the thing that has been left with us is basically CH3, CH2. So that this is what it has been left. So now what will happen is the ethyl group that has been left, and here also a bromine atom is been left. So we could say that there would be a formation of ethyl bromide. So this is the process where we have converted an ethane into an ethyl bromide, so but by using bromine molecule. But again, this reaction doesn't take place by its own. We have to apply a certain condition so that the reaction would occur. So in this case, what will happen is we have to warm the solution, and moreover we have to use a catalyst in this case, so that catalyst can be acted as anhydrous, that is AlBr3, that is anhydrous aluminum tribromide. So this is the thing that we have to use in this condition, and so as we could name it as a bromination, where we have converted a particular alkane to a alkyl bromide. So that is the thing that we have did in bromination process. So now talking about the next one. So the next one is basically, now we are talking about the iodination process. So the third process is, that is, if I talk about part C of halogenation, that is iodination. So again, the definition would be the same, that is, it is a process where we replace the hydrogen of an alkane with a iodine atom by using iodine molecules, and that is the thing that where we convert an alkane into an alkyl iodide, especially because we are talking about iodination, so therefore we have to convert into an alkyl iodide. So in this case, suppose if I take a molecule the same like C2H6, which is called to be ethane, and in this process, suppose if I have made a reaction with iodine, so this iodine reaction that takes place here, so now the result that I would get, or the product that we could get, is now basically CH3 CH2I plus HI. But there are more conditions that it would require, because this is not a reaction that would take place by it only. It requires certain conditions. So this is the product that we will get, that is for sure. But yes, that are kind of the conditions that we have to apply, and this kind of reaction takes place in presence of an oxidizing agent, and that kind of oxidizing agent is nothing but HGO, that is mercuric oxide. So this mercury oxide is the one that we will apply in this reaction, so as to form or so as to convert basically ethane to ethyl iodide. But this reaction will not be balanced, because the thing is that we have observed here is the iodine is present 2 times in the reactant side, while that in case of the product side it is 1. So that's the reason that we have to multiply this by 2. So now the thing that we will get is basically so there are basically 4 iodine atoms, and now we are going to balance it. So in this case, basically the thing that we could get is basically we could see that the Hi2 will also be. So now to balance the reaction, what we are going to do is, now we are going to that is the Hgi2 will be formed. So for that, Hgi2 will be formed, and we could also observe that the hydrogen molecule that has been left is being converted into H2. But for that, we have to balance this alkane also. So therefore this alkane will be now been balanced, and in this process basically the formation of ethane to ethyl iodide will take place by the stoichiometry that has been changed in this format, where 2 times of C2H6 has been involved with 2 times of I2 in presence of basically HGO, that is the mercury oxide, and this is how we have got ethyl iodide and Hgi2 plus H2. So this is known as iodization process that we have did. So that is the reason that we have said already that the halogenation process, it will take place in a particular condition. That is, when it comes to the chlorination, then the condition is only for the presence of UV light, that is the presence of sunlight. So in that presence, only the reaction will take place. And talking about the bromination, then the bromination of the reaction will take place in presence of, that is AlBr3 or anhydrous aluminum tribromide. And talking about that is iodination, then iodination will take place in presence of iodine as well as with the presence of a oxidizing agent, and in this case the oxidizing agent was nothing but HGO. So this is how the halogenation process is. But yes, there are few kind of other reactions also that could be explained with the halogenation process, and that are as follows. Suppose if we have the reaction, suppose if we have a alkane like this one, N-butane. And in this process, basically, we have to do a particular kind of halogenation. So suppose in that case, suppose if I am considering to be reacting it with chlorination, or we are reacting with chlorine molecule. So suppose N-butane is been reacted with chlorine molecule in presence of basically UV light, that is nothing but sunlight. And so what is the answer that we could get, or what is the product that we could get? So first of all, so as to understand that what are the products, or what is, or what are the product that we could get, so let us understand that how can we write the structure of butane. So for example, we could write the structure of butane in this manner also, that is CH3, CH2, CH2, CH3. And now this has been reacted with Cl2, so I would write it over here like Cl2, that is Cl bond Cl. So this is for just for an easiness, I've made it in this format. And so this is will be reacted in presence of UV condition. And so what is the product that we could get? The first possibility is that we could get HCl, that is the thing. So the byproduct will be the HCl itself. And suppose if the hydrogen has been eliminated, or hydrogen has been replaced by the chlorine atom, and that hydrogen that has been removed from the alkane is from primary carbon atom, that is this CH3 methyl group, then the product would be CH3, CH2, 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 Cl. So this is the product that we will get. So this would be the first kind of product that we could get. Or might be the second possibility is that the chlorine atom will take away the second carbon atom, or we could say the secondary carbon atom's hydrogen atom, so making it to be form this kind of product, that is CH3, CH2, CH. Now this would be the CH3, this would be remain the same, while the hydrogen of this carbon atom would be replaced by the chlorine atom. So now this is where we could get. So these are the two possibilities that we could get, and we don't have, or suppose if we can't replace the hydrogen of the third one. Why? Because if we replace the hydrogen of the third one, the same molecular formula, or the same structural formula that we will get, that is of the second one that it has been formed over here. So what does this implies? This implies that the chlorination process, or any kind of halogenation process, when it takes place in a straight chain, so there is possibility of different kind of products. And that's the reason when the reactant that has been used as N-butane, then we have a possibility that we could get basically 1-chlorobutane, or else we could get 2-chlorobutane. So these are the possibility that we could get. So this is a kind of reaction where we could get this kind of possibility. But what if I have applied this kind of chlorination or any kind of halogenation in this molecule that I am going to represent? That is the molecule. This is the molecule, and the name of this molecule according to the IUPAC name is very easy, because we have did the IUPAC nomenclature also, and now it has been found to be basically 2,2 dimethyl. That is the total number of carbon in a straight chain, or in a continuous longest chain is 3. So the 3 carbon atoms when it comes to an hydrocarbon, and more specifically that is a saturated hydrocarbon, is called to be basically propane. So now this would be called as, the name would be in a single word itself, but because I have to write the reaction over here, so that's the reason I have made it over here. So now suppose if I am doing chlorination, so that's the reason I will involve Cl2 in presence of UV light, and I will warm it. So what is the thing that we could get? So among this, 1 chlorine atom will replace the hydrogen atom of the methyl group that have been present, and 1 hydrogen atom will be removed in the form of basically HCl. So now what is left with us? So the thing that has been left is nothing but CH3, CH3. Here it also be CH3, while here it would be basically CH2, Cl. So this is the product that we get. Suppose if the reaction takes place or if the replacement of the hydrogen have took place from this methyl group, then we will get this product. And any other condition, suppose if it has replaced this hydrogen also, then also we would have got the same product. So in this case, basically, we could say that the chlorination of 2 or the halogenation of 2,2 dimethyl propane will give us only a single kind of product, and that is what you are observing here. So what would be the name of this thing? So this is the IUPAC name that we are talking about. So in this case, the halogen atom should get the least number. So we'll start the number from here. So therefore this will be the first one, second and third. And we could see that in second position and again in second position methyl group has been present. So therefore the name of this kind of molecule would be basically 2,2 dimethyl. And moreover, we could see that at first, at first carbon atom, chlorine has been also been present, or chlorine atom has been present. So therefore, the name of this could be written as. So now we could write the name or the IUPAC name of this as, because chlorine has been present on the first carbon atom, and moreover we could see that the chlorine is the one which has an alphabetical order, and we will give the priority to the chlorine atom because it starts with the word C, the alphabet C. So therefore we could name it as 1-chloro 2,2 dimethyl, and the total number of carbon that is present in straight chain is basically 3. So therefore it could be called as propane. So this is the one that we'll get. So at anyhow, suppose if the chlorination takes place over this carbon atom or over this carbon atom, any carbon atom, we will get the same kind of product, that is nothing known as 1-chloro 2,2 dimethyl propane. So this is the one which is I was talking about. So there are different conditions, and yes, there are different possibility also so as to form a kind of a particular product. So that's the reason the isomers can also be formed during this halogenation process. And talking about the next process, especially about the chlorination process, that is, the chlorination process is not a single step process, because suppose in chlorination process you have got this to be replaced by, the hydrogen has been replaced by Cl, but it is not necessary that only one hydrogen will be replaced by Cl. All the hydrogen atoms that are been present in an alkyl group, they all can be replaced by the chlorine atom, because in this case what we are discussing is, we are discussing that chlorine atoms reaction takes place in presence of UV, that is in presence of sunlight. So this reaction will make the reaction so tedious and so fast that all kind of hydrogen would be replaced by the chlorine atoms that are being present in the molecule or that are present in a reaction. So that's the reason we are now going to start with a new topic that is known as mechanism of chlorination. So this is a very important concept that we are talking about. So let us discuss mechanism of chlorination. So now we are talking about mechanism of chlorination. So this is basically a majorly we could say that this is a 3-step process where a chlorination reaction takes place for a particular alkane. So the main process that takes place in this kind of reaction is, that is chain initiation, second is chain propagation, and ultimately chain termination. The word here, it applies chain initiation, chain propagation and chain termination. The reason behind that is the reaction doesn't stop. The reaction goes on continuing, and that's the reason it forms a chain, and that's the reason it was necessary for us to discuss that why this kind of process will happen, when we could see that the general reaction that we are going to talk about. Suppose if I take a chlorination process of methane, that is what we are going to discuss about. So let me give the glimpse of that also, and then we will move towards the mechanism of chlorination. So then only you would understand that why and how the chlorination process takes place for a particular alkane, that is for methane. Suppose if we have a molecule like methane, that is CH4, and in this case suppose if I have applied a chlorine molecule, so I have applied chlorine molecule in presence of UV light and I have warmed it. So the answer that, or the product that we could get, is basically CH3Cl. So this is the product that we know as basically methyl chloride. But the reaction won't stop here. Again, the methyl chloride will be in the contact of the chlorine molecules that are in the solution, or that are basically in the reactant mixture. So now the thing that will happen is this CH3Cl, or this methyl chloride, will again react with the Cl2 molecules that are been present in the reactant mixture, and that's the reason now this would basically form basically CH2 Cl2 plus again HCl. So this is known as dichloromethane. So this is dichloromethane. But again, this reaction won't stop over here. So now what will happen is this dichloromethane, that is CH2Cl2, will react with again a Cl2 molecule in presence of UV light and will heat it, and again in this case we'll get one hydrogen will be replaced here. So now in this case we'll get CHCl3 plus HCl. So now this molecule can be called as trichloromethane, or commonly it is known as chloroform. And further, after this process, carbon tetrachloride will be formed. That is again a process will happen. So this is a process where we could see that the replacement of hydrogen atom will go on until all the reactions or all the hydrogen atoms are being utilized. So in this process we could see that because of the chlorine atom that undergoes the halogenation process, and that also in presence of UV light, or we could say in presence of sunlight, that's the reason this reaction goes on continuing, and that's the reason we have mentioned in the mechanism of the chlorination at each and every step that we have mentioned: chain initiation, chain propagation, and chain termination. So now this is the main thing that we are going to talk about. So the overall reaction that we have discussed, when we have studied the mechanism of this kind of process, it was found to be that this mechanism was because of the radicals that has been formed. So the radicals is now been formed because of the chlorine atom that undergoes in the formation of a free radicals of chlorine in presence of sunlight. So that's the reason we are going to talk about what is chain reaction, chain initiation, and then we will go on further. So now talking about the first process that takes place, that we are discussing about the mechanism of chlorination, that is chain initiation. So the main reaction takes place is because of the chlorine atom that has been involved in presence of UV light or in presence of sunlight. So now in this case, suppose if we have a chlorine molecule, suppose if I am representing it in this manner, that is Cl and Cl, and this is basically a gaseous molecule, and in anyhow, suppose if I have introduced that is UV light, so as the reaction could take place in such a manner that the bond between this Cl and this chlorine atom will break homolytically, and because radicals are being formed because of a homolytic fission. So suppose if the homolytic fission has been occurred in this case, so now what will happen is we will get basically Cl radicals. So these are the free radicals that we have formed, and these free radicals are so energetic that it will enforce the other molecules that are being present in the reaction mixture, so as to involve a kind of breaking of bonds, and that is basically known as they will try to influence to form a particular kind of reaction. So in this case, this is the first step that we have involved, that is basically known as chain initiation, because this is the process when it will happen, then only the overall reaction will happen. So this is the first thing, that is to initiate the reaction. Cl molecule, that is Cl2 molecules, undergo homolytic fission so as to form Cl radicals. So this is the first step that we have involved. So now what are the second step, that is when it comes to chain propagation. Once the reaction has been initiated, it will propagate or it will move on. So we are talking about that. So the next is chain propagation. So chain propagation will involve two steps. The first step is, because in the first step that we have got to know that the chlorine radicals has been formed, and now this chlorine radicals that has been formed, now this will initiate, or this will try to influence, or this will react with the CH4 molecule so as to form a particular kind of product. And what are the particular kind of product that it will form? Let us check it. So what is the particular kind of product that it will be formed? So let us check about that also. So in this case, basically the Cl atom that was being produced from the first step, and in this case basically now it will be reacted with the CH4 molecule, that is the methane molecule, and the result would be formation of, that is, methyl radical, where one hydrogen and one Cl will be removed. So we could also represent this reaction as this one. Suppose if I have represented in this manner, suppose Cl radical has involved with carbon, hydrogen. This is how we have made the reaction. And suppose if the homolytic fusion takes place over here, that is one hydrogen, this hydrogen will be converted into hydrogen radical, and this hydrogen radical will be combined with the Cl radical, that is the chlorine radical, and then we could see that the both will form a bond between them, and yes, one molecule is being produced. So this HCl will be produced as a byproduct. But what is remaining with us? We could see that this CH3 molecule, this is the radical which is been formed because the homolytic fusion has been takes place over here. So now the thing that has been left with us is basically CH3 radical. So this is the thing that we have got in the first step of the chain propagation. So this is not the overall reaction that has been over in the chain propagation. There is also a second kind of reaction that will take place. And what and how? Because in this case, HCl that has been formed as a byproduct that will be removed out. But now this methane, that is the methyl radical that has been formed over here. So even this is a radical that has been formed over here. This would react with the other, that is this chlorine radical that has been formed, and then it will form a product. So suppose now I am representing the second reaction of the chain propagation to be the second reaction, in which, that is, the methane radical that has been formed. So now that will react with the chlorine atoms, and now even this methyl radical is a very reactive species, and it is a neutral species electronically, but it is more reactive because the valencies are not been fulfilled yet. So that's the reason it is a more reactive species. That's the reason it will react with the other chlorine molecules that are not being influenced or that have not been broken, and now this will initiate, or this will make the reaction in such a way that we would get, that is, CH3 Cl. This is how we have got, because of this methyl radical, even this has undergo homolytic fusion, and we have got Cl radical. So in this process, what we have got to know that again a Cl radical is being produced, and this Cl radical will try to influence the other molecules also to undergo a homolytic fusion, and that's the reason that the reaction will go on continuous, and that's the reason it is called to be a chain reaction. So now this is the product that has been formed. So overall, what we have did is that is when it comes to the net cell reaction or the overall reaction. So therefore, the overall reaction is, simply we could say that we have introduced CH4 in presence of chlorine gas, and that too under UV condition, and now we could see that the overall reaction has been converted into CH3Cl plus HCl. So this is nothing but the chain propagation that we have did. As well as we have involved the chain initiation also. So this is the two kind of process that has taken place, that is chain initiation and chain propagation, so as to get a product of CH3Cl. But as we know that this reaction won't stop, because the Cl radical that has been produced, it will try to influence other reactant mixtures also, and that's the reason the chlorination will go on. So this chlorination process will not stop until it has been terminated. So that's the reason now we are going to talk about the termination of the chain reaction. So what is chain termination? Chain termination is nothing but the end of the reaction, and how the reaction would be end. Because in the reaction that we have studied about the chain initiation and chain propagation, we have got to know that again we could see at the second reaction of the chain propagation that the chlorine radical is again formed. So the chlorine radical is the one which has been formed, and as well as we could see that in the first step of the chain propagation the methyl radical was been formed, and even that is a very reactive species. So they will try to react with other kind of the mixtures that has been involved, and that's the reason in that kind of process, suppose if any kind of radical will combine with the other radical and so as to form a particular product, so at that process, because of the radicals are now which are being a very highly reactive species, and now because they are being involved or they have formed a bond with the other kind of that is radical, so now the reaction will be stopped because there is no further radical formation will happen. So this is what we are going to discuss about, that in chain termination the following process will take place. Suppose in this process, suppose the methyl radical that has been produced, suppose in this way, that is the CH3 radical that has been produced. Suppose if this CH3 radical has combined with the chlorine radical, suppose if this step happens, then what we'll get? We'll get basically CH3Cl, and that is nothing but the required product that we needed, that is to convert a methyl to methyl chloride. But this could also happen with the termination of the involvement of the other radicals. Suppose if we have again, suppose if the CH3 molecules would be there, and again the CH3 molecule would be reacted with the other CH3 radicals. So therefore the process is we could form, that is CH3 bond CH3, basically known as ethane. And ultimately we could see that if the chlorine radicals are being formed during the reaction, and in this case if two chlorine radicals will form a bond between each other so as to form Cl2. So now once this kind of process happened where one of the radical has been formed a interaction with the other kind of radical so as to form a bond between them and so as to neutralize, and moreover they have converted from a highly reactive species to a stable product or to a stable molecule. So in this process basically now we could say that the chain termination has been happened, and that's the reason the chain reaction will stop. So this was a small mechanism that I was represented about the chlorination of the mechanism of chlorination. So this was it. And now let us talk about the another type of the process that we are going to talk about, that is basically nitration. So next process that we are going to talk about, or the next chemical property that are being shown by the alkanes, that is what we are going to talk about, that is nitration. So the involvement of the nitration process of an alkane will result in the formation of a nitroalkane. So this is what we are going to represent and what we are going to showcase in this reaction, that is what is nitration actually. The nitration is nothing but the introduction of a nitro group, that is NO2 group in the alkane by replacing one hydrogen atom of an alkane. So the reaction is very simple to understand, that is suppose we know that alkane is can be represented as RH, as we know. Suppose this is an alkane and we have reacted it with nitric acid, and nitric acid is nothing but HNO3, and under that is high temperature. So suppose the temperature is basically 423 Kelvin, and basically here it is 698 Kelvin. From 423 Kelvin to 698 Kelvin is the temperature that we have to provide, and the HNO3, that is the nitric acid that has been used in this process, should be concentrated. So if this is the process that we have made, so what will happen is the H2O molecule would be liberated, or that would be removed out, and we could see that the product that has been obtained is nothing but RNO2, basically nitroalkane. So this is a general reaction where we could see that in nitration process, basically we know that it is a process where the replacement of the hydrogen is done by, that is NO2 group of the nitric acid, and this kind of process is known as nitration of alkane. So the temperature that is required, it requires high temperature. The reason behind that is because in this case basically the water has been removed, and if water is not removed, then this overall reaction can be reversible, and again this would give us an alkane. So that's the reason the concentrated HNO3 is being used, so as to get the nitro alkane, and moreover the reaction should be in a forward reaction. And just for introduction of the nitric acid, we also we can also introduce that is sulfuric acid, that is H2SO4, because sulfuric acid is been known to be as a dehydrating agent, and that's the reason it will remove out the water, and hence the reaction would be in a forward reaction, that is there would be a conversion of alkane to nitroalkane, and there will be no conversion of nitroalkane to back to alkane. So that is the reason the reaction conditions are being maintained. So this is the general reaction that we have mentioned for nitration of alkane. So let me give us a few examples. So now it is very easy to understand that how the nitration process can be done for an alkane. Suppose if we have an example like CH4, that is methane. Suppose if methane is a molecule that has been reacted with nitric acid, that is HNO3, but this nitric acid can be also been written as HONO2 in a very simple format, and we will heat it, and again the temperature would be the same, that is 423 Kelvin and that is 698 Kelvin. So it would be the same, and the thing that will be left with us is, because we are heating it under high temperature, so this OH molecule or this OH group of the HNO3 molecule will take away the hydrogen of the methane so as to form basically H2O. So the thing that has been left is a methyl molecule is, or a methyl group has been left, that is CH3, and in this case the NO2 group has been left. So therefore making the product to be known as CH3NO2. So this is the product that has been formed. So therefore the product name would be also a very important concept that we have to make, that is when the reactant was being used, it was basically methane. And this is the nitric acid that we have used, and moreover we have used a concentrated nitric acid so as to remove the water as a byproduct, and to get the nitromethane as a product, and that's the reason we can convert the methane to nitromethane, and overall the process that has taken place is basically known as nitration. So we could also give an example like this one that we have. Suppose if we consider the reaction to be for the nitration of ethane, so we have included HONO2, and that also in a concentrated solution, and we have heated at high temperature, so therefore we have got water as a byproduct, and we could see that the product that we will get is basically C2H5NO2, basically known as nitroethane. So this is the nitroethane that we have got. So this would go on regularly, that is from methane, ethane, we could prepare a straight chain or nitroalkane, but this is not always necessary. Why? Suppose if we have taken this kind of alkane, that is a higher alkane, for example if we have considered like butane. Suppose if butane, that is CH3 CH2 CH2 CH3, suppose if this undergoes a nitration process, then what will happen? So suppose if this will undergo nitration process, and the nitration process is nothing that involves basically HONO2. I've represented it in this manner, and that also with the tremendous heating. So the thing that I could get is I could get multiple products. The reason behind that is the same as we have did for chlorination or halogenation of a higher alkane. So in this process, one of the OH suppose have taken the hydrogen atom of the primary carbon atom, or we could say the first carbon atom of the alkane. So suppose if it has taken the hydrogen atom, so therefore what is the product that we would get as a byproduct? That would be H2O. So the answer that we could get, or the product that we could get, is basically the first kind of possibility that we could get is CH3 CH2 CH2, again that is CH2 and NO2. The name of this product is being because the total number of carbon atom in this molecule is found to be 4, and along with that of NO2, so making this product to be called as nitrobutane, while this was butane. So this is nitrobutane. The other possibility that we could get is when this OH group will take away the hydrogen of the second hydrogen, the second carbon's hydrogen. So therefore the thing that we could get as a product is will be basically, we could write it as C2H5, then CH, here it would be NO2 that will be attached over here, while this would be remain the same, because this is the CH3 that is here and no kind of substitution has taken place over here. And while in this case basically the substitution will take place where the one hydrogen atom will be removed as H2 when it has been involved with the OH, and the rest is we have got here. So the name of this would be basically 2-nitro, that is the overall carbon atom in this case is 4, so making it to be called as 2-nitrobutane. So therefore this is 2-nitrobutane. So these are the two possibilities that we have got. But yes, one more possibility that we could get in this overall process is we could get a formation of an alkane, and a smaller alkane. How? Suppose in this case, suppose if the reaction takes place in such a manner that we could get this one as a product, where we could see that the bond between the carbon and carbon will break in such a manner that we could get CH3, that is CH2, CH, because one hydrogen has been replaced, because one hydrogen will be removed from this case, and on that position basically what will happen is a NO2 group will be attached over here. So therefore one H, suppose it has been removed over here, and now in this case basically we could say that the nitro group has been attached like this one. So now this is been done, and the thing is left with us is basically CH3. So CH3 is the one that will be combined with the other one so as to form basically CH3OH. So this is how it forms. So now there are other different products also that could be formed. For example, there we could also form that CH3CH2 NO2. So this is the one that it could form. So there are other possibilities also. I am writing in this case here itself. That is, we could get CH3 CH2 NO2. Okay, so this is the one that we would get, or else otherwise we would get, that is CH3 NO2 is also the product that we could get. So that's the reason that if the number of carbon atoms are more, or if we say that if the hydrocarbon, that is if the alkane is a very long chain, and we do the nitration on that kind of process with a concentrated that is nitric acid, so in that process we could get multiple kind of products. That is, for higher alkanes we get multiple types of products. That is this one that we have got to know. So this was related to the nitration, that is what we have did. That is the second type of property that we have did among all the chemical properties that we have earlier discussed. The first one was basically that is the halogenation. The second is the nitration that we have did, and now talking about the third one, that is pyrolysis. So let us talk about the third kind of chemical property, or third kind of property that have been shown by the alkanes, that is pyrolysis. So now we are going to talk about pyrolysis. So what is actually pyrolysis? Pyrolysis is nothing but the reaction of the alkane in absence or in the limited supply of oxygen, such that the alkane will now be converted into alkene, or in that process basically the carbon-carbon bond will break in such a manner so as to produce lower alkanes, or we could say as lower alkenes also. So what is this kind of process basically known as pyrolysis? Let us talk about that. Suppose if we have a molecule like CH3, CH2, CH3. So what is actually pyrolysis? Pyrolysis is nothing but the conversion of alkane to alkene or smaller alkanes with the absence of the oxygen. So we have to heat that particular alkane, then only it will undergo pyrolysis, because in the pyrolysis the thing that has been involved is the breaking of carbon hydrogen and the breaking of carbon and carbon bond. So therefore that requires tremendous amount of heat. So basically pyrolysis is nothing but heating of the alkane in absence of oxygen, and so as to convert into that is alkene or alkane or smaller alkane that we are going to talk about. So let me give you this example so as we could understand that what is actually pyrolysis. So in this process, basically, suppose if we had tremendously heated this process. So now we are talking about the third kind of chemical property, that is pyrolysis. And suppose if in this condition, if we have heated it, so as we have mentioned earlier, that is, we could see that carbon hydrogen bond can break and carbon carbon bond also can break. So suppose in this condition, if one hydrogen is being that is, it forms a bond between the carbon atom and even that breaks. And here also, suppose if one hydrogen is been dissociated by breaking of the bond between carbon and hydrogen, so the thing that has been left with us is basically CH3 CH double bond CH2 with evolution of hydrogen. So in this case, what we have did is we have converted an alkane into alkene. So this was alkane and now it is basically alkene. So this is how we have converted alkane into alkene by using pyrolysis. But in this case, the breaking was done by only the carbon and the hydrogen. But we could also involve by the breaking of carbon and carbon. So that's the reason there are different possibilities. So making the pyrolysis to be divided into three parts. So now we could dissociate the pyrolysis into three parts. Basically, pyrolysis is being divided into three parts, or there are different three kinds of pyrolysis that we are going to study. The first one is that is dehydrogenation. The second one is cracking. And the third one is aromatization. So in all this process, that is in dehydrogenation, in cracking and in aromatization, the thing is the breaking of either carbon hydrogen and the carbon carbon bond takes place. So in this process, basically we could get an alkene, we could get a high evolution of hydrogen gas, we could get a lower member of an alkane, or we could get a lower member of an alkene also. So these are the things that have been distributed in three types. That is, talking about the first one, that is when we are talking about dehydrogenation. As the name suggests, that dehydrogenation is nothing but the removal of the hydrogen molecule from a alkane. So in this process, basically the first example that I had mentioned in this process, it was nothing but dehydrogenation process. As we could see that the hydrogen molecule has been eliminated or has been removed from the alkane so as to convert alkane into alkene. So this is a kind of basically a process where we could form a carbon-carbon double single bond to a carbon-carbon double bond. Talking about the cracking, cracking is the one which involves the breaking of carbon and carbon so as to get a lower member of a hydrocarbon. And talking about aromatization, so it is nothing but it is a combination of different kind of the alkanes so as to form into an aromatic compound like benzene. So because benzene is one of the aromatic compound, so in this process basically the reaction or the breaking of the carbon carbon or the breaking of the carbon hydrogen takes place in such a manner that the alkane is now been converted into an aromatic compound. So that is aromatization. So now let us discuss about each of it in a very deep sense. So now talking about the dehydrogenation process. So this is a process where we could see that the carbon and hydrogen bond will break in presence of tremendous amount of heat. So in this case, suppose let me give you an example so as you would understand. Suppose if I have represented it as CH3, CH3. That is, if I have taken ethane and if I am heating it with a tremendous heat, then what I could observe is the bond between carbon and hydrogen will break such that I would represent it in this manner also. So now this would be easy to know that how the reaction will take place. So in this case, basically the carbon and hydrogen bond will break, and here also the carbon and hydrogen among all the three, one will break, and in this case we could see that these two hydrogen are now being free because they have been broken. So therefore there is the reason that they will form hydrogen molecule. So the thing that is been left with us is basically CH2 and CH2. So now is to balance this valency. So this bond and this bond, this electron and this electron, they will combine with each other so as to form a bond. So therefore the thing that we could get as a product is CH2 double bond CH2. So this is a process where we have converted an alkane, basically known as ethane in this case, is now been converted into ethene by removal of a smaller molecule, that is H2 molecule. So this is what the dehydrogenation means. And talking about the next thing, that is talking about the cracking. So cracking means cracking means the one a kind of process where we could see that the bond between carbon and hydrogen is been broken, the carbon and carbon bond is been broken, and so as to form a smaller alkane and alkene. So this is what we are going to express about cracking. Suppose if we have taken an example like this one, like suppose this is what we have, that is, this is propane, and if it undergoes cracking process, that is, if it undergoes a breaking of carbon hydrogen, breaking of carbon carbon, and yes, and formation of some lower kind of alkanes, so that is what it happens. Suppose what happens is, if the hydrogen is been broken from here, that is, one hydrogen is been removed from this carbon atom, so now one hydrogen will be broken, will dissociate from this carbon atom from which it has been associated, and now one thing is that even this, that is this CH3, that is this methyl group, will also be dissociated. That is what we could see, that the carbon and carbon bond is now been broken. So that is what we have discussed. So in this case, basically the carbon and hydrogen bond is been broken, and in this case basically the carbon and carbon bond is been broken. So in this case the thing that it will happen is, if one H has been dissociated or one H has been lost in that process, so therefore this will be CH2. So this is CH2, that is as it is. So now because of to balance the valency, or so as to complete the valency, a double bond will be here. But meanwhile, if we will see that this is a methyl group that has CH3, that is the hydrogen number of hydrogen is in this case is 3, but one hydrogen has been eliminated from this case. So now in this case we could see that that CH3 will be combined with this hydrogen so as to make as CH4. So this process, basically what has happened is, we have converted a propane which consists of a 3 carbon hydrocarbon. So now it has been converted into an alkene, as we could see here, that this is an alkene, and with a lower member of an alkane. So this is the lower member of alkane that we have got to know, basically known as a methane. So therefore the propane, which is considered to be a higher member of a hydrocarbon when it's been compared to that of a methane. So now after the breaking of the bonds, or we could say after the thermal decomposition of in this process, basically what we have saw that it has been converted into smaller member of an alkane, and as well as we have got an alkene. So this is a process basically specifically when we are talking about cracking, because the previous one that we have talked about, that is dehydrogenation process, where only the carbon and hydrogen bond has been broken, but while in this case the carbon and hydrogen as well as the carbon and carbon bond is also been broken in the overall process, so making to be known as the process to be called as cracking process. So the last process that has been remaining when we are talking about pyrolysis, that is aromatization. So let us talk about aromatization. So we are going for that. So the condition for aromatization will be different, because the thing is, when we have did for dehydrogenation require a particular heat, a particular amount of heat, while in for a cracking process more amount of heat was being required, as well as sometimes catalyst can also be involved. But now we are talking about aromatization, so let us talk about that. So aromatization is nothing but the involvement of the alkane that undergoes the thermal decomposition so as to form such a molecule that it will form a aromatic compound like benzene. So now in this process, what is going to be involved is we were going to take a hydrocarbon which consists of more than 5 carbon atom, that is a straight chain carbon atom. That is, now suppose we are talking about hexane. So suppose if we have taken a carbon atom or if we have taken a hydrocarbon atom which consists of more than 5 carbon atoms, that is, suppose if we have taken hexane. So in this case, let us see that how the process will take place and how the aromatization will undergo so as to form a benzene like compound. So let us talk about that. Suppose if we have a compound like N-hexane, and we know and we will distribute it in such a manner that it would be very easy to understand. So suppose we are going to write the structural formula of the N-hexane. So therefore it consists of basically 6 carbon atoms that are aligned in a straight chain. So therefore this is the first, second, third, fourth, fifth and sixth, and all the hydrogens are now been substituted here. So, and moreover there is no carbon-carbon double bond because it is the one that we are talking about, an alkane. So all the hydrogens here are being fulfilling the valencies of the carbon. So the process will undergo that is thermal decomposition in such a way that a benzene will be formed, but the benzene would be formed in such a manner where we could see that the hydrogen and hydrogen bond, they will break. Suppose in this case these are the two hydrogen molecules that would break and break the bond between carbon and hydrogen, making to be released as H2 gas. And moreover here also we could see that the H2 gas would be released, and here also. But talking about the valency, as you could see, this carbon has a valency of here as 1, 2, 3, but the fourth one would be filled by if it involves with the first one. So that is the thing, that this whole reaction will now be involved in such a manner that the formation of benzene would take place. So that's the reason. Suppose if we have heated it with a tremendous temperature and yes, followed by some few conditions also, and that condition is we have to apply the pressure from 10 atmosphere to 20 atmosphere, and moreover we could use the catalyst like Cr2O3, or we could say as alumina, that is Al2O3. So in presence of this catalyst, and if we heat it tremendously, then we could say that the formation of benzene would take place in such a manner that once again, if I would explain that even this H, that is the total number of carbon that it should remain is 6, and moreover it will form a cyclic form, and this hydrogen will also be removed in the form of H2, so that this carbon will have fulfilled this carbon atom's valency, and that's the reason they will form a ring shape. So now let us see that what is the thing that we would get. We would get basically the reaction would tend in such a way that we would get basically 4 molecules of H2, that is this H2 would be the first, second, third, and involving this 2 to be the fourth mole of H2 molecule. So therefore 4 molecules of H2 has been eliminated in the form of gas. So what is remaining with us? The thing that is remaining with us is 6 carbon atoms, and they will form in a cyclic chain or a like a cyclohexane. But let us see that how does it forms. So for that, 1, 2, 3, 4, 5, 6. These are the 6 carbon atoms that we know that have formed in a cycle form, and each of the carbon atom, as you could see, it possesses 1 hydrogen. So therefore this is the hydrogen that it has been possessing. And talking about the bonds, that is, we could see that this all reaction has been involved in the breaking of carbon and hydrogen. Basically, when we are talking specifically that it undergoes dehydrogenation process, and moreover it is an aromatization process also. The reason behind that is it is forming a compound which is similar to that of a benzene, or itself a benzene. But this is an example where we have taken an N-hexane, but it is not necessary that we have to only take N-hexane. We could take more number of carbon atoms than that of the 6 carbon atoms, or than than that of the 5 carbon atom. That could be an heptane also. So even though if we undergo or if we make an aromatization in that process, then also we could see a aromatic compound or a benzene like structure in that. So in this case, basically we could see that the carbon and hydrogen molecules, the carbon and hydrogen atom here are now have no valency left so as to fulfill, because hydrogen has been left out. This hydrogen molecule has been left out. So how they will balance their valency, or they fulfill their valency? By formation of a double bond. That is, they have made a dehydration process. So you could manage anywhere. So this is the process where happened, that carbon and carbon have formed a double bond over here. Then you could see an alternate single bond, and then again you could see a double bond over here because this hydrogen has been eliminated. So now here would be a formation of double bond. So this is the formation of a double bond, and after that you will again form a carbon-carbon single bond, which is over here, and again carbon-carbon double bond will appear because hydrogen molecule has been eliminated from there. So now this is what benzene. So this is how we can prepare a aromatic compound. So this in this case is benzene from an alkane by using a aromatization process, or specifically we would say in a general manner, that is pyrolysis. So if we do a pyrolysis on this molecule, that is N-hexane, by using certain kind of catalyst and providing a condition, then we could convert that into an aromatic compound. So this was an study of pyrolysis that we have did, but for that let me give you a question so that we could understand that more about pyrolysis. And the question is in this manner. This question is based on pyrolysis itself, and in this case what we have to do is we have to write the structure of all the possible alkanes or alkenes that would be produced on pyrolysis of N-butane. So for first of all we have to write the N-butane structure. So for that I'm writing in the form of, because butane consists of 4 carbon atoms. So this is the first, second, third and fourth, and all would be occupied by the hydrogen. So therefore this would be, all the valencies of the carbon would be occupied by hydrogen, so making to be this as hydrogen, and this is how we are filling it. So this is what we are making the N-butane to undergo pyrolysis, and we know that pyrolysis involves different kind of steps, or three types of pyrolysis that we know as dehydrogenation, cracking and aromatization. But since this is the one which doesn't consist of 5 carbon atoms or more than 5 carbon atoms, then that is for sure that this won't undergo aromatization, but yes, it can undergo, that is cracking and dehydrogenation. So let us see that what are the products that it would be from if it undergoes a pyrolysis process. So talking about the first product, suppose if I would say that if the hydrogen over here and hydrogen over here, if this two gets removed from this overall molecule, then we could find that a carbon-carbon double bond would appear here, so as to make the valency complete of carbon. So therefore we could see that and moreover we could also say that the homolytic fission would also take place in this process, and the carbon-carbon double bond would be formed. So talking about the main point, that is talking about the product that would form. So the first product that could possibly form will be CH3, CH2, C, and here there would be double bond. So therefore now here we could write it as CH2, and here would be H. So the first thing that we have got is, and what would be the name of this thing? That is methane, ethane, propane, butane. It is basically butane, but more specifically, as we could see, because it contains 4 carbon atom, it would be called as butane, but it is not a butane because it is not an alkane, it is an alkene. So therefore the name of this would be but-1-ene. So the name of this would be but-1-ene. So this is the first possible product that we could get after the pyrolysis of N-butane. Then talking about the second one. So second one would be also the same. Suppose if this 2 hydrogen gets eliminated from this molecule, then the double bond would appear here in the middle. So as we could say here, so therefore we could get basically CH3, CH double bond, CH single bond, CH3. Basically it would be known as but-2-ene. Again, this is the possibility that we will get. So if it has been formed this form, so it could also be formed with the other possibility, that is a formation of another kind of alkene. That is what I am going to represent. That is, it would be, that is CH3, C double bond, CH2, single bond, CH3. As you could see that the total number of carbon atom is also been the same, that is 4, but it is not necessary that in pyrolysis it will remain the same. It can be reduced also. So in this case the total number of carbon atom is been same, and moreover we could see that it has undergone an rearrangement form so as to get a product known to be, that is 2-methyl. We could write it as 2-methyl, methane, ethane, propane, prop-1-ene. So this is the product that we have got. So this is the third possibility that we could get, but there are more possibilities also. So till yet we have got alkene, but there are more possibility to get an alkene. So for that, suppose the next one that we could get is, suppose in this process what happens is, if 3 carbons are been left and the carbon-carbon bond has been broken, and we could see that among this 1 hydrogen will be moved over here so as to form a smaller alkane, that is we are specifically talking about cracking. So suppose if it undergoes cracking, then what is the thing that we could get? We could get the following one, that is the fourth possibility is we could get, that is CH3, CH double bond, CH2. So this is the thing that we could get. And what would be the name of this thing? It would be simple to analyze that the name of this would be prop-1-ene. Simple. So, and yes, there would be more possibilities, so let us check it and let us see what is the possibility that we could get. Suppose in this case again a cracking process takes place where the carbon and carbon bond has been broken from, but not from this side, but suppose it has broken from this side. So the thing is, it will break from here, while 1 hydrogen will move away to that side so as to convert this whole alkane to a smaller alkane. Now it is butane, so it would be converted into basically ethane, but by forming a double bond or by forming carbon-carbon double bond, or basically alkene known to be in this, the carbon-carbon double bond will occur, so therefore this will be converted into basically CH2 double bond CH2, basically known as ethene. So this is what we have converted into alkene, but yes, there are a possibility of alkane also. So what are the possibility of alkane? Suppose, and this is only possible if we look this structure, and if we analyze that suppose if the bond breaks from this side, that is if the bond breaks, and we could see that there would be a formation of carbon-carbon all there would be left is carbon-carbon single bond. And even though suppose if the carbon and hydrogen bond breaks and 1 hydrogen would come over here, so as we could get a possible isomer, a possible product, that is propane. And what are the other products that would be formed? So that could be written as, suppose this was the 6th one that it has been formed, and sorry sir, बीच में आ गया, continue करते हैं. So this was the 6th one, and let us see what is the 7th one that we could get. So if we break this molecule in such a way that 1 hydrogen will acquire here, because in this case we got to know that formation of lower alkanes is also been possible. So in this case, suppose we could get another lower alkane, that is CH3, basically known as ethane. And talking about the last one, that is the 8th one, even 8th would be formed. And earlier also we have discussed, suppose while breaking the bond between this carbon and this carbon, 1 hydrogen would go over here so as to form a smaller alkane, or the smallest alkane among this whole and butane, that would be CH4. So that is basically known as methane. So this is all the reaction that was taken place in that we have did in pyrolysis. So this is what the reaction is. So till yet we have did 3 kind of the process, or 3 kind of the process or chemical property that would occur in alkane. That is it was nitration, it was pyrolysis, and yet it was halogenation. So 3 kind of process that we have did, and the next one that we are going to talk about, it is combustion. So let's talk about combustion of alkane. So friends, we have saw that in chemical properties we have talked about that is halogenation, then we have talked about the nitration and pyrolysis, and the last topic that we are going to cover is that is combustion of the alkane. Even this is a property where we convert a particular alkane into the carbon dioxide, and the conversion of water is also happen in this process. That is, so in this case what we could see that the combustion of alkane can be known as a reaction in which alkanes on burning in excess of oxygen forms carbon dioxide and water vapors, and this kind of reactions are known as basically combustion reactions. So the pyrolysis reaction and this reaction are of different, because in this pyrolysis basically what happens is we burn or we decompose the compound like suppose alkane, but that is happening in absence of air, but in this case it happens in excess of air. And moreover we could see that in this case the carbon dioxide is being produced and water vapor. So these are the products that are being produced in the combustion reaction, and the thing is the combustion reaction is basically known as an exothermic reaction also. It is an exothermic reaction, so therefore combustion reaction it is exothermic reaction, where the during conversion of an alkane to the carbon dioxide and water vapor, heat is also been evolved in that process, and that is the reason the combustion reactions are called to be or they also show the exothermic reactions. So for that let me give an example. Suppose if we have an alkane like CH4. So CH4 is the one which is an alkane and which will undergo that is a combustion reaction. So that for this would require the presence of oxygen. So in excess of oxygen only the combustion reaction will happen for an alkane. So therefore CH4 will react with oxygen so as to produce the same number of carbon atom that it has, that is the number of carbon atom in the reactant side is 1. So therefore in this case the carbon dioxide will be produced which consists of only 1 carbon atom, and we could see that the water is also been removed, but this reaction is not been balanced. So therefore to balance this reaction what we are going to do is we are going to multiply it by 2, and similarly we are going to multiply this also by 2, because the number of hydrogen here is 4 on the left hand side or basically on the reactant side, but on the right hand side, that is on the product side, it has been found to be 2, so as to balance the hydrogen also, and simultaneously the oxygen also now is now been balanced. And this process will happen only if we provide tremendous heat. And so the tremendous heat is basically not required in this thing, because the thing because it is not like pyrolysis that we have to heat it in absence of air, because in this case oxygen is already present. So even though if we have heat it in presence of oxygen, the overall reaction will be an exothermic reaction. The reason behind that is oxygen has been involved, and whenever a combustion reaction takes place that is in presence of oxygen, then it is called to be an exothermic reaction. So therefore in this case basically heat is also being evolved. So we have to provide a certain kind of heat, a certain kind of temperature for this so as to get happen, and yes, the more amount of heat is also been released in this process, known to be as a combustion reaction. So this was an example where we have converted that is methane to carbon dioxide. And let us take another example. Suppose if we have propane, that is CH3 CH2 CH3. This is how we represent the structural formula of propane. So this is what we have represented. And suppose if we are reacting it with oxygen, or if we are if this propane is undergoing a combustion reaction, so therefore the answer that we could get, because the total number of carbon in this case is basically 3, so therefore in this process what will happen is 3 moles of carbon dioxide will be produced, and yes, water will also be produced, water vapor in the form of vapor. So therefore this is a gaseous state molecules or compounds that they will form, and this is it. But there will be release of heat also, so therefore this is the amount of heat that would be released. Suppose I have mentioned it as heat itself, because it would be different compared for different reactions, or for different alkanes the heat of reaction, or we could say that would be different. So the reaction here that I have mentioned here is not being balanced, so we have to balance that also. So for us to balancing that, I will multiply it by 5, So if I multiply it by 5, then the total number of oxygen atoms on the left hand side, that is on the reactant side, is being 10. And in this case, basically, till yet it has been it could be calculated that the total number of oxygen here is 6 plus 1, that is 7. So therefore what we have to do is we have to multiply this by basically 4. So now this is now 6 plus 4, it will make a total of 10 atoms of the oxygen atom that are present on the right hand side or that are present on the product side. So this is how the reaction will occur in presence of heat also, that we will do, that we will provide a certain temperature, and then the amount of heat will also be released, and that amount of heat that would be released, that would be more than that of the reactant's heat. So that is the reason it is called to be the exothermic reaction. So in this reaction, basically what happens is the conversion of propane is now been converted into carbon dioxide. So that's the reason that we say that the more the number of carbon atoms, then it is possible to say that more the carbon atoms will be produced and more the water molecule will be produced, and yes, more will be the heat. So that is the reason that we could see that petrols, diesels, this all are basically the hydrocarbons that consist of more number of carbon atoms that are attached in a straight chain, or basically we could say higher alkanes are also being used as fuels, as we know, as petrol and diesel. So this is what we are using, and even to use that methane is also a alkane that is being used in our daily that is in domestic purposes, like for LPG gas, or we could say for that is CNG, which is used in fuel, as a fuel. So therefore it is used in that also, because methane is undergoing a combustion reaction so as to produce carbon dioxide plus heat, and this heat is the one that we require so as to cook food. So this was basically known as combustion reaction, and this is all the reactions that we have did for alkane, that is the chemical properties of alkane. So that was it that I wanted to explain. And so let us do another thing, that is, if we have did all this kind of reactions and all the kind of chemical properties, so now we are going to do a kind of so now we are going to do a reactions, and let us see that what would be the product if the reactants are being given to us. So let us talk about that also. So this is the question that they have provided us, and we have to convert this thing, that how will you effect the following two-step conversion. That is, the first question that has been given is we have to convert methane into ethane, and methyl bromide to ethyl bromide, and again acetylene to nitroethane. But the thing that is been that they have been asking is it should cover two steps. So from conversion of methane to ethane, it should have at least two steps so as to give the product as a ethane. So let us try the first question that has been given to us, that is the conversion of methane to ethane with a two-step process. So if we have to convert methane to ethane, so the first thing that we have to do is we have to do the bromination. So we are talking here about the conversion of basically methane to ethane. So this is the thing that we have to do, and moreover, if we could see that the total number of carbon in methane is basically 1 carbon, and the total number of carbon in ethane is basically 2 carbon. So we have to convert a 1 carbon molecule to a 2 carbon molecule. So how that is possible? See, the first thing that we are going to do is we are going to convert the methane into a methyl halide. That means we are going to do a halogenation process. And in that halogenation process, if we have got any kind of halogen like Cl, Br or I, that would be reacted, that is the methyl iode, that is the methyl halide that would be obtained on the first step, will now be used in the Wurtz process so as to convert the 1 mole of methane that it had, 1 mole of methyl iodide, and now it will be form a 1 mole of ethane, because two same methyl group, they will attach towards each other so as to form ethane. So let us talk about that also. Suppose the first thing that we are going to do is, because in this case we are involving the first step, so in this case basically the CH4 will undergo a halogenation process, and in this halogen we could take any one of the halogen like fluorine, chlorine, bromine or iodine, but we should also consider about the that is reactivity. So it has been found that suppose if we have used chlorine, so therefore if we have chlorine in the reaction, then we know that it will take in presence of UV light, and the reaction will go on continuous until all the hydrogens are been utilized, or all the hydrogens are been replaced by the halogen, that is the chlorine atom. But so that's the reason we are not using it here. So the thing that could be controllable is the use of bromine. So that's the reason what we are going to do is we'll use bromine in presence of, that is, anhydrous AlBr3, and we'll heat it. So the thing that is with us in this process, or in this first reaction, it would be basically CH3Br plus HBr. So this is the first step that has been involved in the conversion of methane to ethane, and now not yet the ethane has been formed. But we could see that the product that has been obtained over here, that is CH3Br, or we could say methyl bromide. So that methyl bromide can be utilized to convert that species into ethane. How? By using or by following the Woods reaction. So in this case, what will happen? I'm writing the second step, and in this case basically I will use CH3Br twice, and the Woods reaction takes place in presence of sodium metal. So therefore sodium metal is also being introduced, but in presence of dry ether, and we will heat it. So in this case what will happen is one Na will take away one Br, while the other sodium will take away another Br, so as to form, that is, 2 NaBr as a byproduct. And the thing that is been left with us is this methyl group, this methyl radical and another methyl radical, because there are 2 moles of methyl bromide that we have used. So in this case, suppose if 2 moles of NaBr has been released, so therefore we could see that the 2 methyl groups are remaining, or the 2 methyl radicals are been remaining. So that's the reason they will form this as a product. They'll combine with each other and will form ethane. So this is the method that we have applied for, that is in 2 steps, where we have converted methane to ethane. Was so simple. So even this question was even necessary, because we can convert, that is, methane to ethane by following these steps. So that is what we have did by applying the 2-step process. So now let us understand that what is the second question that they have asked. So the second question says that we have to convert the methyl bromide to ethyl bromide. So this is what we have to do. But the thing is, it should happen in such a way that it would require 2 steps, so as to convert from methyl bromide to ethyl bromide. So how can we do that? So let us talk about that. So the thing that have been asked is, we have to convert methyl bromide to ethyl bromide. So this is what they have been asked, and we know that methyl bromide consists of basically 1 carbon atom, and ethyl bromide consists of basically 2 carbon atom. The reason that we are paying attention towards the carbon atom, because we know that there are certain reactions where we could see that after the completion of reaction, the amount of the carbon gets reduced in terms of a particular product. Just like in combustion reaction, we could see that if a hydrocarbon consists of 3 carbon atoms, and then we could obtain 3 carbon atoms. But in pyrolysis, we see that that kind of alkanes are now being distributed, and we will get a smaller alkane, or a higher and a bigger alkane, with the evolution of that is a smaller methyl group or hydrogen group. So that is the thing where we could see that the carbons are being dissociated, and we could get smaller number of carbon atoms. But in this case, that's the reason what we are observing. We are observing that whether the carbon atoms are being changing in which proportion, means they are increasing or they are decreasing. And that's the reason that we have learned the reactions of, or we could say that the chemical properties of the alkanes. So now let us come back to this point, whether we have to convert, that is, methyl bromide to, that is, ethyl bromide. So how can we do that? So first of all, to convert methyl bromide into ethyl bromide, what we have to do is we have to do basically a Woods reaction. The reason behind that is, in this case, basically whenever we will do a Woods reaction, then the methyl bromide will now be converted into ethane, and then the product that has been obtained from the first step can be utilized to form ethyl bromide. So let us talk about that. How can we convert that? Suppose if I'm talking about the first step, and in the first step basically what we have is we have basically methyl bromide, so therefore we could write it as CH3Br. So I can't convert into directly into methane, because even that would require more steps so as to convert into ethyl bromide. So the thing that it comes in our mind is we can do a Wurtz reaction. So if I do a Wurtz reaction, then we could see that 2 moles of methyl bromide or alkyl halide is being used along with 2 moles of sodium as a metal, and in presence of dry ether. So the result that I could get is I could get 2 moles of NaBr plus CH3 radical, and again a CH3 radical will be obtained, so making to be formed as CH3, basically known as ethane. So this is the ethane that we have got in the first step. So what we are going to do, we are going to utilize this first product, and the first product would be in this manner, where it would be utilized. And the thing is, we have to convert the ethyl bromide into we have to convert the ethane into ethyl bromide now. So it is a very simple process, that is we have to do a bromination or halogenation when we are talking about. So basically we have to do bromination reaction in this case. So therefore the thing that we have to introduce in this case is we have to introduce bromine molecule. The reason behind that is we need ethyl bromide. So this is the ethane that we have obtained, and now this ethane can be converted into an alkyl bromide or alkyl chloride or alkyl iodide also. But the thing that we specifically need is we need ethyl bromide. So that's the reason we have introduced Br2, and this will take place in presence of anhydrous, that is AlBr3, and we'll heat it. And the thing that we could get is one of the H among this 2 carbon atom, one of the H will be taken away in the form of HBr. So therefore HBr would be then nothing but the byproduct, which is hydrogen bromide, and the thing that is being left with us is a ethyl radical or a ethyl group and a bromine atom, or we could say as a bromine radical also. So in this case what we will get is basically that is C2H5Br. So this is nothing but ethyl bromide that we have. So therefore this is the case that when we have successfully converted a methyl bromide to that is ethyl bromide by using 2 steps that was been asked for. So this is the second reaction that we have did, but yes, we have to follow the third question that also that they have provided to us, that is we have to convert acetylene into nitroethane. So they have said us to convert acetylene into nitroethane. So let us talk about that. That is so talking about acetylene, acetylene is nothing but a carbon-carbon triple bond hydrocarbon. That is when we are talking about acetylene, that is it is nothing but an alkyne known as basically ethyne. So this is the first step that we are talking about. So this is ethyne, and it is nothing like an alkane. So the thing that we have to do is, yes, we have to do the hydrogenation process, because this is an unsaturated hydrocarbon and not even a carbon-carbon single bond hydrocarbon, basically saturated hydrocarbon. So therefore we have to convert this unsaturated hydrocarbon to a saturated hydrocarbon, and moreover we could see triple bond in this carbon, between carbon and carbon bond. So therefore it requires basically 2 moles of hydrogen, and that too in presence of Rene nickel, and we'll heat it. And this is a kind of addition reaction, so that in case no byproduct would be formed, and only the product will be formed in this form, that is CH3. So as to explain, suppose if this is the 2 hydrogen that we have, and this is the total amount of 4 hydrogen that we have, so ultimately making the 2 hydrogen to be attached over here and 2 hydrogen to be attached over here. So that is the case in when the first 2 hydrogen are being attached, so therefore the triple bond will be converted into double bond. And next, another if hydrogen is being added, now the second double bond will be converted into single bond, so therefore making this to be a saturated hydrocarbon known as ethane. So now for this ethane we have to convert this into nitroethane. So it is a very simple step that we have to do, that is CH3 single bond CH3. So the nitroethane that we have to make is only possible if we do a nitration process. So for that we need a nitrating molecule, so that is nothing but a nitric acid. So that's for reason that is we are going to use HONO2, or we could say that nitric acid, and that should be also concentrated, and we'll heat it with a certain temperature. So as now this OH will take away one of the H of the methane or of the ethane, and now what we could get as water as a byproduct, and the thing that has been left with us is basically a ethyl radical and NO2, that is this group would be remaining. So therefore the thing is C2H5 NO2 would be the byproduct, or it would be the main product, while H2O will be the byproduct. So this is how we have converted, that is an acetylene, that is basically known as ethine, to nitroethane that we have. This is nitro and this is ethane. So nitroethane that we have converted. So it involved 2 steps, and yes, this question is now being done. So that is how it was simple. And yes, the thing that we will do about this kind of question is we should know the chemical properties, and we have did successfully that all the chemical properties that was been shown by an alkane, and that's the reason now we are able to solve this kind of questions or this kind of reactions that they have been asking for. So this is how we have solved this kind of reaction that was being provided to us. But yes, there are different kind of the questions that also can be asked, so we are going to talk about that also. The question can be asked in this form, that is we have to complete the overall reaction and to predict that what would be the A, P, C and D in the following sequence of reaction, and yes, we have to rewrite the overall reaction also. So the thing that we have to obtain is A, B, C and D in this reaction, and in this case what we have got is we will get basically at the end of the reaction we will get N-butane. So by predicting or by assuming that this would be the product, so what would be basically the reactant that would have been used as C or as B or as A. So how to identify that what would be the this A, B, C and D in this process or in this reaction. So as you know that the N-butane will be obtained, and in this case as we know that the byproduct would be called as D, because N-butane is the major product that will obtain when is some kind of a chemical is been reacted with sodium and in presence of dry ether, then we'll obtain N-butane, and we'll get a byproduct as something which is a sodium halide. But what would be the halide in this process? That is the main thing that we have to observe, that it might be it would be bromide, or it would be chloride or iodide. So this is the thing that we would decide that what would be the number of carbon atom that C would consist. The thing is, because as we see that in sodium, the sodium and dry ether is being used, basically it is talking about the Wurtz reaction. And Wurtz reaction consists of an alkane, an alkyl halide, which has which will be converted into double the carbon atoms that it has. So in this case, basically, if it contains 4 carbon atoms, because when we are concerning about 4 carbon atoms, which is present in butane, so that means the previous reactant, that is when we are talking about the C, then the C will have basically a 2 carbon. So C will consist of 2 carbon, means it is a hydrocarbon which consists of 2 carbon atom, but it would be an alkyl halide, because alkyl halides are those who undergo Wurtz reaction process. But the halide would be fluoride, bromide and chloride, all it would be the possibility. But what would be the exact thing? That would be because of the assumption of this Br2 Br3. So this implies us to understand that the halogenation process would take place on B, but specifically bromination will take place, and that's the reason, because of the bromination of B, we will get a product that would involve bromine as the halide. So that's the reason we will get something which has nothing but an alkyl bromide. This is what we will get as an alkyl bromide, and that alkyl bromide will consist of 2 carbon atom. And talking about what will be the B, that is so talking about B, because alkanes undergo bromination, because this is the process where B is undergoing a halogenation process, and specifically when we are talking, then this is basically a bromination process. So an alkane is the only one that that undergoes the halogenation process. So in this case, basically, if we see that during the conversion of an alkane to an alkyl halide, the number of carbon remains the same. So in this case, since the product C is been 2 carbon atoms, so therefore we could say that even the B will have basically 2 carbon atoms, and this would be nothing but a hydrocarbon, basically an alkane. So this is what we could decide, and the total number of carbon would be basically 2. ये बहुत खुजली होता है यार, ये क्या है इस रूम में? Continuation. So now, as we could see that the B will have basically 2 carbon atoms, and the B is obtained if the A undergoes a reaction with NaOH and in presence of CO. So this is nothing but a decarboxylation reaction where A has been converted into B, forming 2 carbon atom. But in decarboxylation, 1 carbon atom get less. So this is the reaction that we have did earlier also. So that is the reason the A will consist of 3 carbon atoms, because during decarboxylation 1 carbon atom or 1 carbon atom gets less from the overall hydrocarbon or from the overall sodium salt of carboxylic acid. So in this case, suppose if we are forming or we are getting 2 carbon atom, that means the previous one, or that is the parent sodium salt of carboxylic acid, will consist of overall 3 carbon atoms, making to be said or assume that the A is nothing but a 3 carbon atom compound, but yes, and moreover it is a 3 carbon atom sodium salt of carboxylic acid. So this is how we have predicted, and let us talk about so this is how we have came from reverse, and let us see whether we are in a right theme or not. That is, suppose if we have a sodium salt of carboxylic acid will consist of 3 carbon atoms, and after the decarboxylation process, that is after the reaction with NaOH and in presence of CO, so we will get 2 carbon atom by evolution of a by evolution of Na2CO3. So that 2 carbon atoms, that is the alkane that we'll get, that alkane will be undergoing the bromination process so as to obtain a alkyl bromide, which again it consists of 2 carbon atoms. And now if this 2 carbon atoms alkyl bromide will undergo Woods process, then we'll get a 4 carbon atom alkane, basically known as N-butane. So this is how we have predicted. So that is the reason what we have to do is we have to identify that what will be the A, B, C and D in the process. So now it is very easy to understand that what will be the A in this process. So let us talk it in a very predictive manner, that what would be A by looking at the total number of carbon atoms that have been present in A, that is sodium salt of carboxylic acid. So talking about the reactant A, the reactant A will consist of 3 carbon atoms, and it would be sodium salt of the carboxylic acid. So what I am doing is I am mentioning the 3 carbon atoms here, and that 3 carbon atom is basically involved with a 2 oxygens and 1 sodium atom. So, and will fulfill all the, that is, valencies of carbon. And now I could say that the A is nothing but methane, ethane, propane, because 3 carbon atoms are present, and this is sodium. So I could say that it is a sodium salt of the total number of carbon present in this is 3, so making to be called as sodium salt of propanoic acid, or we could also say it as sodium propanoate. So this is the thing that we could say. So the product, so the reactant A is this one, and what about the B one? So the B is nothing but what we have got. It is basically an alkane that consists of 2 carbon atoms. So an alkane which consists of 2 carbon atoms is nothing but ethane. So therefore this is the 2 carbon atom alkane, basically ethane. So here it would be CH3. I have represented it in alkyl form, so this would be CH3. And the product and the product C that we have got, that is after the B has been reacted. So the product C that we have got is now, because it consists of basically 2 carbon atoms and 1 bromine atom, so basically called to be as an alkyl bromide which consists of 2 carbon atoms. So that's the reason we could represent it by like this one, that is CH3 CH2 Br, basically known to be ethyl bromide. So this is ethyl bromide. And ultimately what we have got as B was, because something is what we could get as a byproduct. So this is the main product that we have got as N-butane, which consists of basically 4 carbon atoms. And in this process, always when a Wurtz reaction it happens, it gives us sodium halide. So in this case, the halide was nothing but the bromine. Bromine atom was present over here in alkyl bromide. So that's the reason sodium bromide it will be produced, and that too 2 moles. So therefore, the D will be originally basically NaBr, and that also 2 moles. So that is what we will balance over there. So this is the sodium bromide. So this is how we have predicted that what would be A, B, C and D. It was very simple, but the thing is not yet been done. The main thing is we have to do the overall reaction of this process, that how the A has been converted into butane. So for that, let us try that out by following this reaction, and let us see that we are going in a right direction or not. Suppose what we have taken is, we have taken the reactant A. It was called to be, that is sodium salt of propanoic acid. So, or we could also say it as sodium propanoate. So this is what we have taken as CH3 CH2 C double bond O ONA, and this reaction takes place in presence of, that is NaOH and calcium oxide, and we will heat it. So if this reaction occurs, then we know that this NaO will take away this NaOC O with this oxygen. So this sodium oxide will take away the carbon and as well as the 2 oxygen and 1 sodium, and the product would be basically this one, that is Na2CO3. And the thing that would be left with us is basically this CH3 CH2, or basically we could say as ethyl one, that is the ethyl group will be remaining, and this hydrogen would be remaining. So overall the reaction would lead us to form a product named as CH3 CH3. So this is the thing that we have, and the thing what we have to do is we have to convert this ethane to such a manner that it should react with Br2 AlBr3. So therefore, suppose if I am continuing the reaction, and suppose if I am continuing the reaction in this way, where that is bromine molecule was being used in presence of AlBr3, and I'll heat it. So what will happen is one of the H will removed from the this among this, or this H among this one H will be removed with the bromine. So therefore the byproduct I would get is basically HBr. Plus we could see that this CH3 would be remain as it is, while the other one would convert it into CH2, and that CH2 will be combined with the bromine atom that has been left over here. So therefore we could say that CH3 CH2 Br is what we have got as this is A, this is B, while this is C. And if this, the product that we have got over here, suppose if this undergoes Wurtz reaction, and we know that in Wurtz reaction what happens is we react with sodium and along with the solvent, basically dry ether, and what happens in this case is the stoichiometry changes and it will change into 2. So 2 moles of ethyl bromide will react with 2 moles of sodium so as to form basically CH3 CH2 CH2 CH3 plus 2 moles of NaBr. So this is what we would get. So the product, this is the product D that we have got. talking about this is the product, this is the reactant A, while this is B, this is C, and ultimately this is D. So this is how we have predicted what would be the, that is what would be the reactant and what would be the product if they have provided to us. So this is the N butane that we have got. So it was very easy to determine this thing. So now let us switch on to, we'll try to solve another kind of the reaction that they have been provided to us. So let us solve that also. And the reactant that we have to complete is this one. That is, in this case, what we have to do is we have to convert A into B, and then B into C and D. And in this case, the process that what we have got is we will get ethane, and we have to predict the same thing that we have did earlier. That is, we have to predict A, B, C, and D in this case. So how can we predict that? So for that, what we are going to do is the simple thing that we have did in earlier reaction. That is, we are going to do in a reverse manner, that so as to predict that what will be the product C, B, and A. So suppose in this case ethane has been obtained, and we see that in this process, that is sodium and diethyl has been used so as to convert C into D. And in this process, basically what happens is ethane has been obtained, and D would be the byproduct. But ethane is the one which has basically 2 carbon atoms. So this 2 carbon atom will be only obtained if the C undergoes Woods reaction process. And in Woods reaction process, what happens is the carbon content of the reactant is half of the product. So therefore, if we see that ethane is basically a product that has formed or that has 2 carbon atoms, then the C will have basically 1 carbon atom. So therefore, this C is nothing but a 1 carbon atom, and we know that alkyl halide undergo Woods reaction process. So therefore, this is C is basically a 1 carbon atom substance that is also an alkyl halide. So therefore, this is basically an alkyl halide. And now in this case, suppose this alkyl halide is been obtained from B. So B is something which is alkane, because only alkane will undergo the bromination process like Br2 in presence of AlBr3. So therefore, the B that we have is basically an alkane. So it will also consist of 1 carbon atom, because in this process basically the carbon atoms are not being get increased or decreased when it comes to halogenation process. So therefore, this is a halogenation process in which the total number of carbon atom would be remain the same. So therefore, if this C as a product, it remains as 1 carbon atom. So the reactant as B, it will also consist of basically 1 carbon atom, and moreover we say that it would be basically an alkane, because alkane undergo halogenation process so as to obtain alkyl halide, and that alkyl halide will undergo Woods reaction so as to form ethane. So what would be A actually? So what would be the A? As we know, as we could see here, that zinc copper couple is been used, and in presence of alcohol, and we see that in this case basically Hi is been the one which is been removed out. So therefore, since this minus Hi, it represents that the alkyl halide, because this is the process, that is when we use zinc copper couple. So zinc copper couple is being used on alkyl halides. So on alkyl halides, when they are being used, and when zinc copper alcohol, when they react with each other, they produce nascent hydrogen, and that nascent hydrogen removes the halide atom. So in this case, the halide atom that has been removed is iodine. That means the A is a alkyl halide that consists of iodine as an halogen atom. So that's the reason we could say that it will also consist of same number of carbon atom that we have discussed in our earlier lecture. So this is what it will consist of, only 1 carbon atom, and the halogen, it would be basically, it would be an alkyl halide, but more specifically because iodine is over here, so therefore it would be alkyl iodide. So alkyl iodide is the one that is A, and that will undergo, that is zinc copper coupling reaction, and that will reduce to basically an alkane that will also consist of 1 carbon atom, and that 1 carbon atom alkane will undergo, that is bromination, to form 1 carbon atoms alkyl halide, and that alkyl halide will undergo Woods reaction so as to form double the carbon atoms, that is it will form ethane, and a byproduct will also be formed, and that is basically NABR or NAI. So it will depend on what we are what we'll take as an halogenation process. So in this case, the halogenation process was basically bromine was been involved. So that's the reason the alkyl halide that has been produced over here, it will be basically alkyl bromide. So if alkyl bromide is now being utilized in the Woods reaction, that means the D will be nothing but an sodium bromide. So let us see that what would be the A if we have got this kind of predictions. So let us concern with A, that what we have got. So in that case, that is the A would be nothing but what we have chosen as a one carbon atom alkyl halide. So one carbon atom alkyl halide is basically CH3X, but the halide or the halogen atom in this process is basically iodine. So that's the reason this is what the A is. That is the name of CH3I can be written as in case of IUPAC name, that is iodomethane. So iodomethane is the one that is A, and that iodomethane will undergo the reduction process and so as to form B. So in this case, the B is nothing but a one carbon atom alkane. So a one carbon atom alkane is nothing but methane. So therefore this is the one that we will have, that is methane. And what about C? That is, we have got to know that C is an alkyl halide which consists of one carbon atom. So therefore the C would be basically CH3, and because in that process, because bromination has happened over here, as you could see, the bromination has been happened, so therefore this would be alkyl bromide. So we would write it as CH3Br, calling to be that as methyl bromide. This methyl bromide is basically the common name, but we could write it in IUPAC name also. The IUPAC name of this would be bromomethane. And talking about the last one that we would get, so talking about the byproduct as the D, so we will get basically sodium bromide. So that is what we have predicted earlier itself. So therefore the D would be basically sodium bromide, or we could write it as NABR. That is sodium bromide. So this has been done, but we have to check whether we are right or not. So for that, just for an instance, we'll write the overall reaction and let us see that the overall reaction will follow the prediction that we have did or not. So in this case, what we have did is we have got to know that the A is nothing but the iodomethane. So what we are going to do is we will write the prediction as iodomethane that undergoes a reaction with, that is zinc copper couple along with alcohol, and in that process what happens is we'll heat it and so as to produce basically HI as a byproduct, and the thing that will be remaining with us is CH4. So now this is what we have got. This was our A, this is our B, and now this B is been now reacted with. So this B is now been reacted with in presence of bromine and AlBr3, and we will heat it. So basically this is a bromination process in which the methane will undergo bromination process so as to produce the product as CH3Br. So this is the product that we will get, and moreover the byproduct would be basically HBr. Easy to estimate. So therefore this would be the product C. And now the C, the product that we have got, it will undergo basically a Woods reaction that involves basically sodium metal and in presence of dry ether. But the stoichiometry that we will apply is this would be multiplied by 2, and moreover this will also be multiplied by 2, making to be the byproduct as basically NABR. And that also the 2 moles of NABR will be produced, plus the main product that will be produced in this case is ethane. So as we could see that there are 2 methyl groups that are being present over the methyl bromide, overall in 2 moles of methyl bromide. So therefore the thing is CH3 will be produced as, and the name of that would be basically ethane. But ethane is not over D, this is over D. So this is how we have predicted what would be A, B, C and D. Very simple that we have did. So this was a very tedious thing that we have learned about the chemical properties of the alkane, and yes, we have did many processes in that also, and yes, we have did this kind of this kind of questions also, where we have to convert from one form to another form. So the chemical reaction that we have did. So thank you friends for watching this video. I hope you have liked this video and you have understood that how and what are the chemical properties of alkane. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.